Welcome to the presentation on difference between crystalline and amorphous solids. I am Ms. K. Janani, Assistant Professor, St. Joseph's College for Women, Tripur. These are some of the objectives that are going to discuss in this video. Solids, properties of solids, types of solids, definition of types of solids, difference between crystalline and amorphous solids, self-assessment, activity, learning outcome and references. Let us first discuss what is meant by solids. Solids are rigid, possess a definite shape and their volume varies with very less with variance and change in temperature and pressure. Solids have fixed shape, size and volume. Let us take an example of table which is having a regular shape, size and volume. We have discussed what are solid. Let us now discuss what are the properties of solids. Solids have definite shape and definite volume. Particles of solids are tightly packed and are not easily compressible. Molecules still move but only vibrate about a fixed position. Intermolecular forces are strong. Do you know what are the types of solids? Yes, you are absolutely right. There are two types of solids based on their atomic arrangement, binding energy, physical and chemical properties. They are crystalline solids and amorphous solids. Let us now discuss what are the types of solids. Crystalline solids are the solids which have regular, repetitive arrangement of atoms and molecules. For example, table salt. Amorphous solids are the solids which do not have regular, repetitive arrangement of atoms and molecules. For example, plastic. The following points predicts what are the differences between crystalline solids and amorphous solids. Number 1. Shape. The crystalline solids have definite, characteristic, geometrical shape. In amorphous solids, it is having an irregular shape. Number 2. Melting point. What is meant by melting point? The melting point of a substance is defined as the temperature at which a substance changes from solid phase to liquid phase. In crystalline solids, melt at sharp and characteristic temperature. In amorphous solid, the melting point gradually softens over a range of temperature. Number 3. Cleavage property. What is meant by cleavage? It is defined as the tendency of the crystalline materials to split along definite crystallographic structural planes. In crystalline solids, when the crystals are cut with sharp-edged tool, they split into two pieces and the newly generated surface are plain and smooth. In amorphous solid, when it is cut with a sharp-edged tool, they split into two pieces with irregular shapes. Number 4. Heat of fusion. The amount of heat required to convert a solid at its melting point into a liquid without an increase in temperature is known as heat of fusion. The crystalline solids have definite and characteristic heat of fusion. Amorphous solids do not have definite heat of fusion. Crystalline solids are anisotropy in nature. Amorphous solids are isotropy in nature. What is meant by isotropy? Isotropy comes from the Greek word isos, that is equal, and tropos, that is way, which indicates that it is uniform in all directions. Example, table salt is an isotropic crystal, that is the crystals are identical in all directions. And the graphite exhibit different material properties depending on the direction, that is it is anisotropy in nature. The crystalline solids are true solids, whereas the amorphous solids are pseudo-solids or supercooled liquids. The crystalline solids have long range order, whereas the amorphous solids have only short range order. The best example of crystalline solids are table salt, which is having an orderly arrangement. The best example of amorphous solids are cotton candy, which is having a random arrangement. These are some of the self-assessment questions. Rubber is an example of amorphous solid. Yeah, it's true. What is meant by anisotropy? It is the property of the substance to exhibit variations in physical properties along different molecular axes. These are some of the self-assessment questions. Rubber is an example of amorphous solid. Yeah, it's true. What is meant by anisotropy? It is the property of the substance to exhibit variations in physical properties along different molecular axes. Based on the above points we have discussed, these are some of the activities to know about the crystals. Collect some of the crystals which are available in our daily usage and predict whether it is crystalline or amorphous. Learning outcome. Now we can able to define the crystals and their types. By learning this unit of crystallography, we are familiar in the field of crystal growth. These are some of the references to know more about the crystals. Modern Physics by R. Murugesan, Solid State Physics by Gupta Kumar. Thanks for watching.